Okay, class, welcome to Cyber Day Part 2. It is Tuesday, September 12th, and we are going through the 2.3 notes today. So, if you'll open your 2.3 notes, we can go through these together. So, we're starting with how to identify if one of the equations that we're trying to solve, which you've seen something like this before. We worked on this in 2.1 and 2.2. And remember, our steps for solving them were these right here. First, distribute if necessary. Second, combine like terms on each side. Then, if you have variables on both sides, you choose which side you want the variables to move to and move them there. And then you finish by just solving like we know how to and how we learned in Unit 1. So, the point of section 2.3 is that sometimes when you go through all those steps, something weird happens. You end up with something that isn't normally what we get. Normally we get something that looks like this, where we end up getting something like our variable equals a number, like y equals 10, or x equals -1, or k equals -9, or -3 equals u. So any one of those is a normal outcome when we solve an equation. But there are some times where we won't get something like that. Let's see what happens when we solve this one right here. So what I'm going to do, I'm going to copy this over and we'll solve it together. So -4 2x plus 1 equals -8x minus 2. So, our first step is to distribute. So we distribute the -4 in. -4 times 2x and -4 times +1. So we get -8x minus 4 equals -8x minus 2. So, we look to combine like terms here, and there are no like terms on the left side to combine since that's an x and that's a constant term. And same thing on the right side. There's a variable term and a constant term, nothing to combine. So, if we go back to our previous homework, what was our next step that we would do? So we just distributed. We could try to combine like terms, which we didn't need to do. Then we move variables to one side of the equation. So, we got to move the variables to one side of the equation. So, what I'm going to do is add 8x to both sides. I'm going to move all my x's to the left side. So, plus 8x and plus 8x. And notice what happens. What's -8x plus 8x? That cancels out. And look at this. It cancels out over here as well. So, we're left with just the -4 on the left. And is that equal to -2? So this is not our normal outcome. We normally get something where we have x equals something that we then have to finish and solve. So, is this a true statement that -4 equals -2? If you're thinking no, you're right. -4 does not equal -2. So, for this one, we write no solution. No solution for that. So remember, this came from the first page of the notes right here. So right here. Okay, so next. Let's see what happens when we solve this one. So I'm going to recopy this over. And we have -5 minus 9x equals 3 times 1 minus 3x minus 8. Okay. So, first step is to do what? Distribute. Distribute. So we distribute this 3 into the 1 and the -3x. So it turns into 3. 3 times 1 is 3. And 3 times -3x is minus 9x. And then this minus 8 just comes down. Minus 8. So we still have -5 minus 9x right there. So what is our next step? Well, if we look back to 2.2 notes, our next step is to combine like terms. Combine like terms. So we're going to combine like terms. So notice the 3 and the negative 8 are like each other. So we do 3 minus 8, which is negative 5, minus 9x. Minus 9x comes down. Minus 5 minus 9x. Okay, so what is our next step? Well, we have to get all our variables on one side. Remember, third step is move variables to one side of the equation. Then we solve if we can after that. So we move our variables to one side. I'm going to move them all to the left side. So I'm going to add 9x to both sides. And we get, oh, look at this. Our x's are going to cancel out of both sides again. So notice we're left with negative 5 on the left equals negative 5 on the right. Look at that. So recall, up here, we got some number equals some other number, which is a false statement, so we said no solution. Here, is this a true statement? Does negative 5 equal negative 5? Yes, it does. That means there are infinitely many solutions. Which, if you want, you can write with the symbol infinity. It's like a sideways 8. That means infinity. Infinity. So, those are the first two problems from the notes right here. So notice how we say infinity means there's no solution. That was this first one. Means there's no possible number that could work out as a solution in the equation. And then infinitely many solutions means every number could work as a solution. So if we plug in any number for x in both of these, it's going to work out and make us a true statement. Okay, so next, let's work a couple of the examples. Just numbers 1 and 2. 1 and 2. So, for number 1, our first step is to do what? We're going to distribute the 3. So I'm going to copy this over here real quick. So we've got 3 times 2x plus 2 minus 3x equals 6 plus 3x. And we are looking at number 1 in the notes packet for section 2.3. So first step is to distribute the 3. So we get 3 times 2x is 6x. And 3 times positive 2 is plus 6. And we bring down our minus 3x equals 6 plus 3x. Our next step is so after distributing, we combine like terms. So notice we have a 6x and a negative 3x that are similar to each other, or are like each other. So we say 6x minus 3x is positive 3x. Bring down our positive 6 equals 6 plus 3x. We're just bringing this down. So our next step is to get all the x's on the same side. So I'm going to move my x's to the left side. I'm going to subtract 3x from both sides. What do you notice is about to happen when we combine like terms here? The x term cancels out, and we're just left with 6 equals 6. And if we remember, is this one more like the one that ended in no solution, or the one that ended in infinitely many solutions? If you're thinking infinitely many because you get some number equals itself, then you're right. There are infinitely many solutions, which I'm just going to write as a infinity symbol. And there we go. So that is our answer for number 1 in the examples in the notes packet. All right, we're going to do number 2, then I'll set you guys loose on your own. So, for number 2, we have 6 times 2x minus 6 equals negative 7 times negative 2x plus 4. So, if we look at number 2 here, first step is to distribute. So we distribute the 6 into the 2x minus 6 and the negative 7 into negative 2x plus 4. So 6 times 2x is 12x, and 6 times negative 6 is minus 36. Negative 7 times negative 2x is 14x, and negative 7 times positive 4 is minus 28. So what do we notice here? What's our next step? Combine like terms if we need to, right? Do we have any like terms on the left side? We do not. Do we have any like terms on the right side? We do not. So we skip that step and we go straight to the get all your x's on the same side. So I know I haven't mentioned yet which side is better, but what do you think would be better? Subtracting 12x from both sides or subtracting 14x from both sides? I kind of like subtracting 12x from both sides because that still allows me to work with a positive number over here in front of the x. So I'm going to subtract 12x from both sides, and we're left with negative 36 equals 14 minus 12x is 2x, and we bring down our minus 28. And now we finish up by solving for x. Add 28 to both sides. We get negative 8 equals 2x. Since this is 2 times x, we finish up by dividing both sides by 2. So we get x equals negative 4. And notice, is this infinitely many solutions or no solutions, or is it just one of our regular problems that we've seen a lot of? Notice, since we got x equals some number, then it is one of our regular problems that we've seen plenty of. So mixed into this homework set, you'll see problems that end up with some number equals itself, which you'll say infinitely many solutions, or you can put that infinity symbol for. Or as you're solving, you'll get some number equals some other number. And if you get that, that means there's no solution. Or there may just be some regular old problems that end up with x equals some number. So there won't be infinitely many solutions or no solution. It'll just be whatever the solution is. So good luck with the homework, and I will see you guys in class tomorrow.